So, okay, first a couple of disclaimers. The first one is, although it says CNET Networks on my slides, I was told to say that this in no way represents anything that they publish or whatever. They just pay my salary and pay for my hotel and all that. The second disclaimer is that it says history in the title, but this is more of a collection of war stories than an actual chronological history. So bear with it. You'll probably find it more entertaining this way, though. So what this really is sort of an explanation of why my hair is gray. Okay, how do I make it change slides? Page down. There we go. Okay. Oh, it didn't work the way I wanted it to. All right. Okay, so what I've organized this into is 10 myths about pairing points, exchange points, whatever you want to call them, and what the truth turned out to be. So first myth, of course, 10 megabits is enough. May East was formed in late '92 when a bunch of internet geeks got together at a Mexican restaurant in Herndon, Virginia, and decided that they didn't want to use a mesh of T1s to interconnect their networks. They wanted something a little faster and hopefully simpler. So they bought a metropolitan Ethernet service from MFS DataNet. It was a service, 10 megabits that ran across a ring of DS3s, proprietary hardware called Magnums. And it actually worked reasonably well for a while, until, guess what? They started pushing more than 10 megabits into it. Then it didn't work too well. That's when I got involved, by the way, to try to figure out why it wasn't working when they were pushing more than 10 meg into it. One of the things that we did after that was right around the time that Ethernet switches became reasonably priced and available, so we got one, stuck it in there, and we're using the Magnums just to backhaul the circuits to the routers. That was the other thing that was unique about the May at the time, was it was distributed. The routers were not co-located with the infrastructure. The traffic was passing around the DS3. So anyway, we brought in the Magnums, brought in the switches, used the Magnums just to backhaul individual point-to-point circuits. Unfortunately, at the same time, Cisco made their routers better so that they would actually send packets faster. And we discovered that the Magnum had this annoying feature that if you sent a packet with the interframe gap too short, but still within spec, it would stop working and required somebody to go and power cycle it to make it start working again. These are the kinds of things that one discovers late at night when the build snaps. Oh, wrong button. So this is a picture of May East in early 1993. There were, as you can see, looks like 6 connections, all on a shared 10 megabit Ethernet. It grew a little bit after that. Okay, the second myth that I remember hearing around the same time, early 90s, when I started playing this game, was that it was only possible to have one exchange in the entire world, because otherwise routing would break. Somebody proposed this thing called a global internet exchange, where everybody could bring in their routers, and there'd be this huge peering fabric, and everybody could peer there, and that would solve all peering needs of the entire world. I don't think that would have scaled too well. Fortunately, nobody ever really tried that. The reality, BGP worked. It could deal with asymmetric paths. It could do hot potato routing, so your packets actually took the shortest path to get where they needed to go. And you didn't need a center of the universe like the NSF net at the top to make everything work. And that was really the big leap at that point. Third myth. In 1993, the NSF came out with this proposal to build NAPs, network access points. What they really wanted was more carbon copies of May East, or something like it, scattered around the country. So that by then they figured out that distributing them was okay. So they came out with this solicitation, which is part of a bigger solicitation to essentially privatize the internet. It would keep the R&E stuff separate from the rest of the world and let provide mechanisms for commercial internet providers to connect, and everything would be wonderful. So of course everybody, all the telcos saw this and said, hey, free money from the government. So everybody tried to build their own NAP design and submit it, including us. And eventually 3.5 NAPs were awarded. But as we saw, it was entirely possible to build a successful exchange point. It didn't have NSF blessing. May West, PAX, whole bunches of regional exchanges all over the place, not to mention the international ones like Links. are proof that the NSF doesn't have to bless something to make it useful. Oh, this one was one of my favorites. Join May East, peer with the world. There were people who actually believed that if you could get a connection to May East, you wouldn't need to buy transit from anybody. This was due to some clueless salespeople and some clueless ISP wannabes who believed what they thought they heard. The reality, of course, was that some of the larger ISPs back then were beginning to realize that they didn't want to peer with every mom and pop regional ISP in rural Virginia or whatever, that there was actually some money to be made by selling them things. So Unet and Sprint and all those others at some point started saying, no, we won't peer with you, we'll sell you stuff. So these ISP wannabes quickly learned that that wasn't going to work, and they either bought transit or went away or something. Myth number 5, if you build it, they will come. Oh, it speaks for itself here. Do you remember May New York or May Zurich? Enough said, I think. Good. They were actually there. I took a wonderful week-long trip to Switzerland to build a May in Zurich. The only problem is they never actually got around to selling it. So nobody came there and it went away. As far as I know, the hardware's still sitting there. Myth number 6, 100 megabits is enough. Well, you can see myth number 1 for the answer to that. May East had by this time evolved into a shared FTDI ring because 100 megabits was faster than 10 and people could connect and colocation would be really cool, and that was the way the fix worked, and for a variety of reasons. And it was a good idea for a little while, but it filled up. Amazing. So the moral of the story is shared media will fill up wherever you have it. You have to plan for that. You need to have an upgrade path ready for when it does. If you don't, then people complain. Myth number 7, peering means never having to say you're sorry. The GigaSwitch, that GigaSwitch was our hardware of choice for May East and May West in late 96, early 97. We were installing them and getting them up as fast as we could. I think PAX had one installed by then too. In any event, GigaSwitch was a wonderful piece of 1970s technology. Unfortunately, we're in the 90s, and the GigaSwitch fell apart under the load that we were trying to push upon it. In particular, it was an input buffered switch and suffered from this phenomenon called head-of-line blocking, which I think we all understand now, but back then it was sort of, well, we have 100 megabits, who'd ever want to push that much data through? Well, we did. So in early 97, Stephen Stewart, who worked for Digital at the time, was up apologizing for the GigaSwitch in front of NANOG. By the end of 97, we still hadn't been able to do a whole lot about it because there was no upgrade path available at the time. So I showed up at a NANOG meeting wearing a target and let people throw things at me. Myth number 8, IXSD disco lights. So here we go. This isn't an actual exchange point. This is a dramatic recreation of one. But for a long time, the most successful exchange point in the US was in a place that looked like this, May East. Okay, myth number 9, ATM will fix everything. 9B, ATM is useless. Well, as you might have guessed, the truth is somewhere in between. There were successful ATM-based NAPs. There actually still are a couple running. I don't know. Just I don't follow it too closely anymore to what extent they have market share. But they're there. It took a long time to make them work. It took a long time to figure out that you need buffering and switches, that you need to do some nice traffic shaping instead of just hard policing, various things. But the lesson I learned from that was ATM is a tool in the toolbox, and there are places where it could be appropriate, and if it is, use it. If it's not, then don't. Should be as simple as that, right? Religion got in the way, but what the hell. And finally, the last one, layer 2 is easy. No. With Ethernet, you have all sorts of fun things like spanning tree to worry about, bridging loops to worry about. Maybe you can just plug and play a simple layer 2 topology, but when you start growing it to enough switches, when you start putting funny things in there, it gets really complex and leads to some really interesting troubleshooting times. Loops being, of course, my favorite, because that took a long time to figure out what was going on there. The other layer 2 technology we used were virtual circuits, ATM, frame relay. Started playing with MPLS a little bit while I was still there. That leads to a different set of problems, path asymmetry being one of them. Even the switch pretends that you have a bidirectional virtual circuit between your endpoints. What you really have is 2 unidirectional circuits. They may lie to you about it and pretend that you have 2. But if half of it goes down and the other half stays up, some routing protocols don't deal with that too particularly well. So we learned that. And as I said before, policing, just hard rate limiting on a virtual circuit leads to some nasty effects with TCP, which doesn't like that. We learned after a while that shaping to try to make the traffic match what the switch wants is far better than just having the switch try to enforce what it wants. And then, of course, there's the hybrids. This is when you try to do both of them together. Anybody ever heard of NetEdge? This way, you get to have the worst features of both worlds. You could have bridging loops and ATM problems at the same time. So, I don't know, this is sort of my lesson of what not to do when building an app. These are lessons that I learned pretty much the hard way over 10 years of doing this. And I'm sure I could go into more detailed war stories about all of them if anybody really wants to hear them. But I'm sure that people will keep making the same mistakes over and over again. I keep hearing about them. I heard yesterday about somebody who wants to build an exchange with a piece of fiber between one city in the U.S. and some city like 1,000 miles away in the U.S. Well, go back and see the one about shared media fills up. Anyway, those are my lessons. I hope somebody benefits from these someday, and thanks for listening.